All right, we're going to try to prove that the left side equals the right side. So as I always do, I'll take that and write it at the very bottom, tangent theta plus secant theta. I'm going to leave a lot of space because this is going to be a nasty problem, I have a feeling. So the first thing I like to do when I see this sort of thing is convert from sine to sine and cosine. You don't have to do that, but I think it'll probably be better to do it. So tangent is sine over cosine. I'm going to abbreviate to for the sake of time. So sine over cosine plus secant is 1 over cosine minus 1 over cosine of theta minus 1 plus 1. Now I'm going to multiply everything by the cosine of theta over the cosine of theta. And when I do that, I will get sine theta plus 1 minus cosine of theta all over sine theta minus 1 plus the cosine of theta. Now I'm going to rewrite this at the bottom like this. And I'm totally cheating by doing it like this, but trust me, it's just going to make life a lot easier. I just factored out a -1 basically in the bottom. The reason I did that is because now I'm going to multiply the top and the bottom by the conjugate of this thing right here, which would be the sine plus 1 minus the cosine of theta. Sine plus 1 minus the cosine of theta. Okay. Now, why would we want to do that? Well, because this will be a lot easier now to multiply these things out. Notice that I've got this times itself, basically. And we know the shortcut for that is just sine squared theta plus 2 sine theta 1 minus cosine theta plus 1 minus cosine theta squared, right? And then in the bottom, you'll notice that it's a plus b times a minus b, which equals a squared minus b squared. Okay? Now I'm going to simplify this as much as I can. So in the top here, this equals sine squared theta plus 2 sine theta minus 2 sine cosine theta plus 1 minus 2 cosine theta plus cosine squared theta. That's in the top. And in the bottom, I have sine squared theta minus 1 minus 2 cosine theta plus cosine squared theta. Let's distribute this negative. There's a negative, there's a positive, there's a negative. Let's see, what can I do in the top? Can I simplify anything? That plus that is equal to 1. And that's it. Okay, so what I have is, so I really have 2, right, on the top. 2 plus 2 sine theta minus 2 sine theta cosine theta minus 2 cosine theta all over. Let's do the same thing on the bottom. Whoops, nope, that doesn't work because that's a negative. So let's convert this. Let's see, I know sine squared plus cosine squared equals 1. So sine squared minus 1, which I have right here, is equal to sine squared minus 1 is equal to negative cosine squared. Got it? Hopefully you understood what I said, because I'm not going to spend any time explaining it. So I have 2 cosine theta at the bottom, and I have 2 of the negative cosine, so it's minus 2 cosine squared theta. Okay, now what I'm going to do is I'm going to factor out two cosine theta from the bottom, and I'll be left with 1 minus cosine theta. Did I do that right? If I factor out a 2 cosine theta, yeah, and then in the top I'm going to group these things. I'm going to group them, let's see, I want a 2 cosine. So I'm going to group this with let me think about this. Now I'm going to factor out a 2 cosine, a negative 2 cosine out of theta out of there, and I'm left with sine theta plus 1. And I'm going to factor out 2 out of there, and I'm left with a 1 plus sine theta. So now I can factor that out of both of those, and I'll be left with sine theta plus 1 and 2 minus 2 cosine theta. So now I'm going to put this 2 back inside here, because then that'll cancel with that. So that leaves me with sine theta plus 1 over cosine theta, and when I divide cosine into each one of those, I get that.